Yo guys, we are back and today we will build a Pump.fun bonding token hunter. So we will look for tokens that are about to be migrated to the Raydium liquidity pool. So let's check it out. Alright, so before we jump into the actual code, I want to give you a quick overview of how a hunter like this could look like. So the script is something that will be triggered, and we will use a Websocket connection to the blockchain using Helios. So the first thing the script will do once it is started is initialize our Discord bot. So we use Discord GS for that, and with initialize Discord bot, I mean we will make sure that our bot is online in our Discord server, and this will only be done the first time the script runs. So once that is completed, we will start a WebSocket connection which will listen to certain logs on the Solana blockchain. And the logs that we will listen for are logs that are related to the actual Pump.fun Raydium migration program, and the things that we were listening for specifically are the remove liquidity, yes, because these will be triggered before a token will be migrated to the Raydium liquidity pool. So we win a bit of time there by looking at these specific transactions and not necessarily looking for the liquidity pool creations. So by using this WebSocket connection, listening to these logs for these specific transactions, we will get back these transactions, and then we will filter them out and use these transactions to go into our next function here. So we will take that transaction related to the remove liquidity, and from that transaction, we will withdraw the signature or the actual the token that we need. And in this case, the token, I mean the mint. So we will use the Helios DAS API for that, and we can just provide it the signature from the log, and that will provide us the actual human readable transaction for this signature. So now we have the transaction for the remove liquidity in the Pump.fun Raydium program. So once we have the transaction, we will send it to a new function called getMintReport, and this function will go to the Pump.fun API, it will go to Dex API, and also to Rugchuck API to create a really nice report for us with all this information that we will then send to our Discord app using Discord GS. So we will also output it into our console if we want to, but the main focus for this is checking all these tokens that are about to be migrated to Raydium from Pump.fun and output it into our Discord. So this is how the hunter for Pump.fun bonding tokens looks like, and that is what we will build in this video. Alright, so before we actually look at the code, I want to show you what we will build. So you can start the hunter by typing npm run, like this, start:hunter. And once you start this, it will output the tokens that are about to be migrated to Raydium in our Discord server. So here you can see that it outputs the mint and description about the token, and then some parameters. And this is the report that I talked about that will check all these things related to the token, like how much replies, the socials, market cap, also when it was king of the hill. All these kind of things will be returned in some kind of report, and that we send to our Discord. So that's what we will build in this video. And with that said, let's jump into the code. So by running that command that you saw, the npm run start hunter, it will start the index.ts file. And this file, it will start initialize Discord, and after that it will start the WebSocket handler. So we can look at the initialize Discord first, and this one is started by providing the Discord channel and the Discord bot. And these two values we get from our environment file, which is stored here in our project. And I can show you how a environment file would look like. Here you would specify the Discord channel that you want to have the bot provide the messages in, and also the Discord bot token. And the bot token you can get from the Discord developer platform, where you can create a bot and then you will get a bot token back. If you want more information on that, you can find it in our VIP program, where I go more in depth on how you can actually set up this Discord bot onto your own server. So if that interests you, you should for sure check it out. But these two values you can find there. Now, if you want to know where you find the Discord channel, you can just go to your Discord server, right click on the channel, copy channel ID, and that will copy the channel ID to your clipboard, and then you can paste it in the Discord channel. If you don't see the copy channel ID, then you need to put Discord into developer mode, and then you will see that option to copy the channel ID. So once you have filled this in, and also the other options or the other things that you can see here, like the endpoints for Helios, Pump.fun. For Helios, you need to provide the keys, and I think that's it. So once you have done that, you can copy this env.backup file and rename it to env.env. So you have a valid environment file. So that's what we need to pull in these two values, and then we will provide it to the initialize Discord function, which we will start here on top. An initialize Discord function will just make sure that our bot will appear online in our Discord server. And I can show you what I mean. So here we have certain bots, and once it's initialized, this bot will appear online. It will no longer be offline. And we need the bot to be online to be able to send these messages into our Discord server. So first thing we do is checking if we received a bot token and a channel ID, of course, because without that we cannot initialize it. If we don't receive it, we will log out like, hey, the Discord bot could not be started because we are missing the token or the channel ID. So if we have these both, we move on. And the first thing we do is create a Discord client connection by using the new client function from the Discord GS library, and here we provide some intents, and these intents are needed to actually make sure that the bot can speak and read messages on your server. So we create a Discord client, and based on this Discord client, we try to log in using the Discord bot token. So we create a client to Discord, and we want to log in with this bot, which is the bot token. So once we try to log in, we also create a listener for the Discord client, and we will listen to an event called client ready. Once the client is ready, once it's connected, we will create a bot channel based on the bot channel ID that we provided. And this we can do by provide a Discord client, channels, cache, get. And then we provide the bot channel ID that we provided in our environment file, and that will also create a bot channel for us. So now that we initialized our Discord connection, these two variables are set, and our function, the rest of our function, will know that we now have a valid connection to Discord with an online bot. So that's what we did first. Once Discord is enabled or initiated, it says here, initiate Discord, the next thing we do is start our WebSocket handler. And the WebSocket handler is the functionality that will listen to the Solana blockchain to actually get the logs, and that's what we specify here. So the first thing we check if was this already initiated before. If not, then we clear the console because we want to output everything really nice. And then we say like, hey, the Discord bot is ready because we didn't get any errors. We moved on to the next stage after initializing Discord, so we can output it like, hey, Discord bot is ready for use, starting the WebSocket. The next thing we do is get our WebSocket URL from Helios. Again, this is specified in our environment file, remember? And based on this URL, we can create a WebSocket connection. And WebSocket is just a function that we import via WDS here. It's a WebSocket library that we use. And here we can create an actual WebSocket connection using this WebSocket URL from Helios. Now, next, we have a few listeners that we create for this WebSocket connection. And one is one that listens to an open. Actually, once it opens, we have also that listens for when we get a message or a logback, and two that listen to if there is an error or when it's closed. So we will look at the first listener first, which is open. So Once our WebSocket opens, we need to subscribe to a method, because if you use a WebSocket, you need to subscribe to a method. And the ones that we will subscribe to is the log subscribe method from Solana. And I can show you what I mean. So if you would go to log subscribe method Solana, you can see there is more information on that here. So this is the actual method for the WebSocket that we will subscribe to. And it says here that it will return transactions for a certain program or transaction that we mention here, and that will return us the log. So if you want more information on this method, you can just go to the Solana documentation, log subscribe RPC method. That is the one that we will subscribe to you. And we do that by creating a subscribe request function that we trigger once the WebSocket has opened. So once it's opened, we trigger this function, and this function is just specified here on top. And as you can see, it creates an object, a WebSocket request object. And as you remember, this is actually the same as what you can see here. It's exactly the same, but the mention that we will do, remember, the mention is the program from Raydium, or from Pump.fun Raydium. So again, I can show you the one that we looked at earlier. We will mention this account here. So, and then by mentioning this account in this log subscribe request, we will get all the logs back that are related to this account. So that's what we do first here. We subscribe to the WebSocket using the log subscribe method for this account. So once we are subscribed, we will get messages back, of course, and these we can capture in the message listener. So that's what we do here. So the first thing we do is, once we get a message back, we will take the data from that message and we will parse it into a object or a JSON object, because it's easier to work with JSON, because we can interact with the object much easier than just plain texts. So that's what we do here. And then we also check if the parse the data as a result or an error, because as you can see here, once we subscribe to this method, this is the subscription, and this is what we will get back. Now, if you subscribe to a method, the first message that we will get back is always a confirmation. And that's what we try to capture here, because this confirmation, they have a certain, certain structure. And if there is no result or it's undefined, then we know that this message that we got back is not an actual log, but it's a confirmation, and that we will also send back to our log, like, hey, we are actually successfully subscribed to this method. So the next thing we check is if we have an error in the message that we got back. And if that's the case, then we will log it out by doing a console log RPC error and then the error. But if it's not a confirmation and it's not an error, then we will move on. And the first thing we do is extract the logs and the signature from this message or this log that we got back, because we want to have the signature to send it to the DAS API to get the transaction back, and also the logs we will need to filter to see if we are actually looking at a log that we are interested in. And that's what we do next. So we first check if the logs that we pulled out from this data that we received is an array, and also if there is a signature. And if that's not the case, then we return, we do nothing. But if we have a logs array and we have a signature, we move on. So the next thing that we do is look at these logs and see if the logs contain the following statements: program log, instruction, withdraw. And I can show you what I mean. If we would go to Pump.fun again and we will click on this remove liquidity signature, if you go down all the way to the logs, these are the logs that we are looking for. There is an instruction here that says program log, instruction, withdraw. So if we return logs from this program and it has this statement in it, we know that it is a remove liquidity signature or transaction, and then we know that's the one we want to have to use or work with further on. So if it's not that, if it's not a instruction withdraw signature, we just let it go, we return, we do nothing. But if it's a signature that has to do with instruction withdraw, we move on and we want to process this signature. And for that, we have a separate function called process signature. We provided the signature, and that function is actually declared here on top. So that's what we will do next. Now that we have the signature from the program that has to do with withdraw, now that signature we will take and we will try to get the transaction from it using the process signature function. Alright, so now that we have this signature from this lock that we are interested in, we will send it to a function called process signature, and we can have a look at that function, what it does. So first thing it will do is taking this signature and sending it to a function that we will use to actually get the human readable transaction back using the enhanced transactions API from Helios. So we will do that by providing this signature in this function called parse individual Solana signature, and we can look at that. We have specified this function here in transactions, and this transactions expects the signature that we provided, and then we will just log out like, hey, we are trying to fetch the actual transaction for this signature. So the next thing we do is checking if we have verbose logging on, because verbose logging is just specified in our config file here. And if it's enabled, that just means that we will output more logs in the console. The next thing we will do is getting our URL, which is stored in the environment file. Again, here, the Helios parse transaction HTTPS. This one is the one that we will use to talk to Helios and get the transaction. So that is what we try to get here. And if verbose logging is on, it will also output that. If it's not on, we will not tell the console. So then we specify the amount of max retries, and with max retries we have a back off strategy to talk to this API to not overload it with requests, because sometimes these logs come in, but the actual transactions, they are not available yet on the API, and to prevent getting a failed fetch, we use a back off strategy, and here we use actually max retries, which we also specify in our config, a max retries count, and then also we specify an initial delay before we try to do the actual request, to make sure that once we receive this signature, that the actual transaction is also available on the blockchain. Now, once we specify these things, we will go through a loop that will try to do try to get this information for a certain amount of tries, and the max tries is what we specified here earlier. So now that we can look at this function to or this fetch to do the actual fetching the information based on the amount of tries, we can have a look at what that does. So again, if we have verbose logging on, we will output it. If not, we will just continue. And here is what we having the logic to do the actual fetch. And we specified a timeout, which we also specified in config, and the signature is the signature that we provided. And we will use the enhanced transaction API from Helios to do this. So what we will provide is a signature, and it will return us a human readable format about this transaction that is, or that has to do with the signature that we provide. So it will provide us information about the type of transaction it is, what the source is, but it will also provide us the mint that this transaction is related to. And that's what we need. We want to have the token mint that this transaction is associated with. And that's what we do by using Axios, sending this request to the enhanced transaction API from Helios. Then we check if we returned data, and if that's the case, then we move on. If not, we throw an error, and we also check if this data is actually an array, and if there is actual data in the return that we got. Then we store it into a variable, and we have types for this specified. And with types, I mean we're using TypeScript for everything that we return. We have types, as you can see, for example, enriched transaction response. This is the response that we will get back from the transaction API. So everything has types, and it makes it easier for us to later get into the object and see actually what we are looking for. So that's why we store this data that we received in this variable that matches this type. Then we check if we actually have data once again, and if we have data or we have an array that is valid, then we will go and get the token transfers, the type, and the source. And the token transfers will hold our mint, the type will be withdraw, and the source will be Pump.fun. And that's what we check here. So hey, the type, is it withdraw? And the source, is it Pump.fun? If that's not the case, then for some reason we are looking to a wrong transaction, but that should not be so. But if that's all fine, then we move on. And we just check again if the token transfers is an array, because we will need an array to see, to find the certain mint. If that array is not there, again, then we cannot really proceed. And I can show you again in types, if you would go to enriched transaction response, what we are looking for is actually the mint. So here in the token transfers, we are looking for the mint. But if the response that we get is actually empty, or these things are not there, then we cannot proceed, because we want to make sure that there is an array and that it array also contains a mint. So that's what we are looking for using this logic. If that's the case, then we move on and we store the mint in the mint variable called mint here. And then we also check like, hey, do we have an actual mint? If not, then we throw an error. And if we have the mint, then we will return it back to our main function. So that's what we do here. Taking this mint, store it into a object that we create called mint response. The mint, we say success true, and the message is also success. So then we go back to our process signature function, because now we know that we got a return. And the first thing we do is check if this return is actually success. Just as I said before, the mint response will have a success variable, and if it's true, then we move on, but if it's false, then we will output the error message. Next, we will check if this this response that we got has an actual mint, just to be sure that we have a mint to continue. And then with that mint, we will move on to the mint report. And that's what I said here, the mint report. Once we have this mint, we will go to a function called mint report, and there we will talk to the Pump.fun API, the Dex Screener API, and the RugCheck API to actually get all these details back and form a report. So that's what we do here. We take the mint that was been returned to us and we put it into a mint report. So to do that, we have a function called getMintReport, and that's also specified in the transactions.ts file. So I can just close this function here and I'll open the getMintReport. So first thing we do is outlook, like, hey, we are now trying to get the report for this mint. We check if verbose logging is on again. And the next thing we do is getting the Pump.fun API that we will use to get this mint information. So it's also stored in our environment file, and we replace the mint, because this URL, if you would look at that in our end file, one for Pump.fun, this is the URL, but the token needs to be specified here. So we need to provide it in this format. So the next thing that we do is just replace this, this string here with the actual mint, and that's what we do with this logic here. And also, if verbose logging is on, we will also output that here. Next thing we do is connecting to the Pump.fun URL, and that is the one we specified here. And then we will get a response, and if there is no response, then we throw an error. And if we do have a response, then we move on and we store that response also again into a type-safe object called pumpcoin. And we can look at that response here. That response will look like this. So once we have that data, then we will extract some of the things that we want, like the mint name, the symbol, the description, the image, the socials like Twitter, Telegram, the website, who was the mint creator, when it was created, once it reached the king of the hill, how much replies it has, and the market cap. So this information we want. And once we have that, we move on. And then we will also look for information related to the actual king of the hill and how long it took. And based on the information that we got here, we can actually calculate like, hey, it took that long to reach king of the hill, for example. We can also calculate or show how long it took since this mint was created. And we do some other time calculations to actually show in Discord. I can show you how long it took, and then we can see, for example, here it was 2 hours ago since this was created. It reached the King of the Hill in 2 hours and 4 minutes. All this information, or the curve fill time, was 2 hours 5 minutes and 59 seconds. That's what we do here with this logic. So then we move on, and we also want to check some information about the creator. And if we have a creator, then we will do another API request to the Pump.fun API for creators. And this one is also specified in the environment file. And this is the URL that we will use for that. And we just have to replace the creator address here with the actual address from the creator. So that's what this logic do. And then we will send the API request to that API, and then we will get a response back from the creator. And if we received a response, then we will look into this response, and the response will look like this. I can show you, since we have types, it will look quite similar to the coin response, but it will be an array, because what we will return is actually the amount of tokens and which tokens this creator created. So that's what we specify in the pump creator value. Then we check how much tokens the creator created. We filter for how much tokens actually reached the Raydium pool. And then we also check the percentage of tokens that reach the Raydium pool. And here we check the total replies and also the average total replies. So now we have the actual creator information, or the token information that this creator actually created. So the next thing we do is check in Dex, and we have the Dex API also specified here in the environment. Dex orders, that's the next thing that we do. We take this API URL and we add the mint to it, and then we will send it to the Dex orders API, and that will return to us all the orders that were created for this token, and that we will also store in a type-safe variable. And then we know how much orders this certain token had, and we can look at here like, hey, let's see where this Dex paid. We can actually extract like, hey, was the Dex paid? So that's based on the order information that we get back. And I think that's here. If there was Dex orders, we get the Dex order data. And then we also return it to our function, but we will look at that later. So one additional step that we do is getting a rug check report. And we do that by sending a request to the rug check API. And also this API is specified in our environment file. It's called rug check report, and we use the rug check XYZ. And to do that, we also send a URL, or we create a URL where we replace the mint once again with the mint that we want the rug check report for. And then we send an API request to this URL from the rug check API, and we check if we have data. And if we got data back, then we will store it into a type-safe object again. We will take the top holders information, and if we have top holders, then we will remove the first one, because we don't want to check the actual pool holder. And then based on the top holders that are left, we will calculate the amount of percent that the top holders have. And that you can see here, if we will look at top holders, we can see that they have 37%. So that's what we get by connecting to the rug check API, getting the holders information, and then check how much percent the holders have. Next, we take all this information and we will send it back to our main function. And what we have here are the Dex orders, the total percentage of all the holders, and all the other information that we extracted from the Pump.fun API. So we take all this information, store it into a mint report variable, and send it back to our main function called index here. And now we have all this information about the token in a nice report called returned data response. And now we just check like, hey, was it successful? If not, we log out the error. And if it was successful, we move on. And now that we have this report, we can send it to our Discord function. And that's what we do here. So the first thing we check is, do we have a bot channel? And remember, the bot channel was set up the first time we ran the script. So we should have a bot channel. And if we have a bot channel, then we will take this report and we will send it to the send message on Discord function. And this function is stored in Discord send. And here we take the bot channel, and that's the channel that our bot needs to provide the message in, and also the report from the token. Next thing we do is extract all this information that we have in the report from the report object that we provided it. Then we create some links. We also extract the image URL. We see if there was an order for a token profile. If so, we create a nice icon. We check if we have social links. If we do have social links, then we create these buttons to click on it. If not, we have this nice X's here. I can show you. If there is no website, it has an X. If there is no Telegram, an X. If there is a Twitter, then it will create this nice visit button here. So that's what we do here. Then we create our links to click on to trade on, for example, Nova, GMGN, or Dex. And the next thing we do is check if we have a description. If we don't have a description, we say there is no description. And then we take all this information and we create a nice embedding for Discord. And that we do by talking to the embed builder, which is a built-in function for Discord GS. And by that function, we can actually build a really nice embedded object. As you can see here, we add fields, we add a description, an author, we set a color. And if we fill all this in, or we create an embedding based on the information that we have here from the report, then we can take this embed and say to our bot channel, hey, I want to send an embed. This is the embed, and if it was successful, log out like, hey, this was successfully sent to Discord. And with an embed, I mean just a card like this. This is called an embed, and by creating this embed, we actually create a nice overview of our token and all its details. So that's a quick overview or a quick code review of how this token hunter for Pump.fun works. And again, all this code is available via our Discord VIP program. So if you don't want to write it yourself, you can get in there and copy the code and just run it. There will also be a video on how to install it into your own Discord. So if you think that is interesting, head over there. Again, if you have questions, you can also put them in the comments. But if you want these questions answered quicker, then again, I suggest you jump into our Discord. I will put the link in the description, and I'll hope to see you there.